Okay, so day 2 notes. Today we are doing one variable inequality. So I know you guys have seen this stuff before in Algebra 1. We're just going to go over it again. All right, so look at your first example. What symbol is this? Greater than or less than? Huh? Greater than. Yes. That is greater than. And in words, you can just write greater than. All right, when you make a graph, I am not going to require you guys to fill in every hash mark. Maybe like 2 to 3, maybe 4. You can choose wherever you want to start. I started with 10. All right, just so I kind of have an idea of what numbers we're playing with. Okay, you can do a few numbers, you can do all numbers. It does not matter to me. Because this is greater than, what kind of circle will I have? Open or closed? Open. So I'm going to go to my 14 and I'm going to make an open circle. Will my arrow go towards the left or go towards the right? Right. The right. Good, because that's where my greater than symbol is taking me. That's all you have to do. Let's look at the second one. What's my symbol here? Greater than or equal to. So you can write greater than or equal to. You can abbreviate that so you don't have that much space. All right, and it tells me I have -5. I'm just going to make -6, negative. Maybe I should try to use a smaller pen. So we have -6, -5, and -4. Well, I have an open or closed circle. Closed. And I'm also going towards the left. Sorry, the right. All right, the third one. What kind of sign do I have? Less than. And I'm going to fill in right here. I have an open circle on 2, and I'm going to draw my arrow to the left. Use everything that is less than 2, including the negative numbers. All right, the fourth one, I have less than or equal to. All right, it shows -10, -11, -9. All right, I have a closed circle on -10. And I'm going to the left. All right, when it says compound, I want you guys to think about this. When we're doing signs, that's what I taught it last year. We know that we either have greater than or less than, right? This is important when we have compound inequalities. This is greater than, right? I know that because I can also make the word or out of that. Do you guys see that? How that greater than became the R? All right, so also on the other side, I can make this less than. Okay? Or goes with greater because that means that my arrows can go opposite directions. So that's what's important, is that they can go opposite. You guys notice? Or opposite, that whole thing going on. All right, it's just little brain triggers. All right, my less than symbol, that means that my inequality looks like a sandwich. Okay, that's where the and comes from. And means it's connected. Okay, so they are together. Wordplay. Think about a sandwich. Spell that right? Yeah. Long summer. Hold on. You guys ever do that on your phone? If you think of a word and you can't write it out?
Yes.
Now I just say it. You know how iPhone has that like talk to text? I tried to, formally. I tried to write the word formally and I could not think of how to write it at all. And I had to say it. It's kind of embarrassing, but that's where we are in the world. You don't have to know how to spell. All right, so let's look at these symbols here. Will this be an and graph or an or graph? And. What did you say? It's an and because it's less than. And I think about sandwiches all together. Okay, so this have a symbol? No, it's a symbol. So we're just gonna write and. That's what's important to us. So to make this graph, I'm going to put -3 here, -2, -1, 0, 1, 2. All right, so there's my number line. Yours can be a little different, make it however you want. And because it's and, I know they're going to be joined together. Okay, my -3, does that need a open circle or closed circle? Closed, because it's saying x is less than or equal to -3. So we're going to put a closed circle there. My other inequality says x is greater than 2, so I need a open circle. Will my arrows go opposite or together? Together, good. There we go. That's my picture. That shows that it is a and graph. Now, for the or graphs, it should not be that hard. Yes, you can look to see whether it is greater than, but it literally tells you right here. See the word or? You don't have to think too hard on this one. If it's an or graph, it says it. So I have -1 and then +4. So -1, 0, 1, 2, 3, 4. My circle on the -1, open or closed? Open. My circle on the 4, open or closed? Closed. And because we know it's an or graph, they are going to go opposite directions. All good here? All right, let's look at this part. It says order matters. Whenever you guys see this, I think you should just rewrite it, okay? I think it's kind of like it confuses the brain. I like to rewrite this, always put my variable first. So I'm gonna put the x first. When you do that, look at your sign here, okay? This sign has like the mouth part of it facing the X, right? So keep that the same. In this case, you have to flip it. Okay, we're flipping everything. And then I'm just gonna write negative. All right, for the second one, that one's good, right? Sound good? Is it?
No.
No, my variable's still on the other side. So do you guys see how if you look at it like this, it doesn't really match? Like if you look at the inequality, it looks like it wants you to shade to the left, right? But that's not what it's saying. This is saying that r is less than or equal to 0. So that means if when we flip it, which we will, r, flip your sign, and then put 0, now it makes sense because you can see your arrow is going that way. Okay, if you don't flip it, it just doesn't make any sense. It looks weird. It looks like it's opposite. Does that make sense?
Yeah.
All right, good. The last one, I'm going to flip it. Right now, it looks like the arrow should be going to the left, it's going to the right, it's all confusing. But it's really saying W is greater than 2, because we always start with a variable. And so now I can graph it. Now I have an open circle, and I'm going to the right. Where it says, what's the rule? The rule is basically what I just told you. You don't have to write this whole long drawn out sentence. The rule is to flip the variable, put that in the front. So flip the variable to the front. And most importantly, make sure you flip your sign. And we're basically going to flip everything. If not, it looks like your whole graph is going to be opposite. Did you guys do interval notation before? Maybe a little bit? I think you guys did set builder. Does that sound familiar? Set builder does. All right, interval notation. The notation to show all solutions in an inequality is interval notation. It is a way that we talk about the graph in math terms. You always want to go from least to greatest. All right, the parentheses are for less than or greater than. The parentheses are also for negative infinity to positive infinity. Brackets are for less than or equal to and greater than or equal to. All right, what that means is when we're trying to talk about a number, right? Like let's say I have a number line here, 1, 2, 3, and I have a dot there and a dot there. Okay? You don't have to write this down, just pay attention to it. My interval notation will be a bracket, and it will be 1 to 3. That's basically saying what my graph is. Okay? If I have a number line, and let's say I go from 1 towards my arrow, this is filled in, right? That means that that number is included. That's why I have a bracket. This is an open circle, right? It needs to have parentheses. So that would be 1 to infinity. Infinities always, always, always have parentheses. Okay, I can't tell you to go to the store and get me an infinite amount of candy. Okay, there's no number there. You have no idea what that number is. It does not exist. It keeps going on and on and on. So that's why it's always going to be parentheses. That's more of an algebra 2 thing, but you guys are learning this year too. All right, so let's graph this. Oh wait, they are. Oh, they graphed the first one for you. All right, the first one is just an example. You have an open circle at 2. Your arrow is going towards infinity. Your interval notation is 2 with the parentheses because it's an open circle, and infinity because it has an open, or because it's infinite. There's some number there. The description. We're not going to do the description. We don't have to do that. All right, let's practice the one underneath it. It's okay for this to just put one number, okay? All right, we have -6. Will I have an open or closed circle?
Open.
Open. Go to the right. Okay, they already gave you your inequality. What is your interval notation? Do I have a, actually let's do the numbers first. We started, oh, it's negative, yeah, started at -6 and we went to where? Infinity. Will I have a bracket or parentheses on my -6? Parentheses because it's an open circle. What about on my infinity? Bracket or parentheses? Parentheses. Because it's an open number. All right, the second one, W is greater than 11. Open or closed? Open, we're going to go to the right. Your interval notation, we're going to have 11 to positive infinity. Will I have parentheses or brackets? You're going to have parentheses on both. There are some times that you may not have parentheses on both. That is an option. But in this case, there we are. All right, I want you guys to do up until, actually, I want you guys to finish this page. Here's your example. I want you guys to finish this, and then we'll check in and move on. Take like 3 minutes. All you're filling out is the graph and the interval notation. And I'm actually going to do the first one with you, so you can see an example of that. We have 8. Will it be a closed or open circle? Closed, so we're going to the right. All right, my intervals are, I have 8 and I'm going towards infinity. For 8, do I have a parentheses or a bracket? A bracket, good. What about for infinity? Parentheses, good, you guys got it. All right, take a few minutes and finish the rest of this page. Fabio, are you with me? Okay, so I'm going to put the answers up. You check your answers with mine. Michelle, you with me? Yeah. Are you sure? Your hair's all over the place. All right. So we have -3, close dot, this way. You guys have that? Good. Josh, are you good with that one? All right, now we have 9. Open circle. That way you should have 2 parentheses.
Yep.
Oh, well, hold on. Okay, so we always read our graphs from left to right. So we're coming from negative infinity to positive 9. They both need parentheses. Don't forget that negative. You have a question? Huh? Because from this way is like towards negative infinity, this way is towards positive infinity. So because we're coming from this side, we read it left to right, negative infinity to 9. Same here, we should get negative infinity to -7. Both parentheses. That was a little tricky. And then the last few. -1 should be a closed circle going to the left. So I'm going to have negative infinity to -1. -1 is going to have a bracket because of the closed circle. And then 18. Closed circle to the left, so that means we have negative infinity to 18 with the closed circle. How did we do on those? Good. Let's have a little quick check. changes, the negatives and the infinities? Good. All right, so here, look at this problem. Or y is greater than or equal to -7, and we have y is less than or equal to -5. Is that and or? I didn't hear you. Yes, it is an and graph. Okay, so because this is an and graph, I'm going to just pick a spot here, write -7, and then -5. I need two closed dots. Because Elisa told us it is and, I know when I have a sandwich. I just draw a little bar between it. It is very cold. I'm sorry. I don't you know what happens. It will be normal, then it shuts off, then it gets too hot. I know it's not a Now if it gets really hot and sticky, let me know how it feels. Alright, the next one. W is greater than 10 and W is less than or equal to 14. And or? Is it or? And I can make a D out of both of these, which tells me that the letter D reminds me of and. So that's an and graph. So we have 10, 14. I clearly did not count in between because it's a little harder for me to write these numbers up here than you guys. I don't have much space. So I have an open circle on 10, a closed circle on 14, and I'm going to draw a line in between. Or? Yep, we know it's or now. Okay, so because it's or, I have -2, I have +3. Worked out perfectly. Open circle on -2, and I'm drawing my arrow to the left. On 3, is that an open or closed circle? Open, and I'm drawing it towards the right. All right. The second one, I have 19 and then 22. On 19, I have a closed circle out to the left. On 22, I have an open circle out to the right. Oh, I forgot to do my interval notation. Interval notation for OR graphs is a little different. You start left to right. You can see? I start left to right. So I'm coming from -infinity. Where does my graph stop? Stops at -2 for a little bit. And that's going to be a parentheses. You guys ever seen these little U's that mean union? It means and. You see all this like empty space in the middle? That means we're just skipping over it. So I went -infinity to -2. I have my union. My graph starts again at +3. And I go to +infinity. That is how we write the OR graphs for interval notation. It's a little bit more work there. And on the bottom one, same thing. I'm coming from -infinity. And I stop at 19. It's 19, you know, bracket or parentheses. You can go now. Did I have bracket or parentheses on 19? Bracket, good. Keisha's not here or Kim, but it's a wide open room, yeah. I think Kim left and Keisha flew through. All right, at 22, parentheses or bracket. Parentheses, 22 towards positive infinity, always parentheses. All right. Okay, let's finish this up. When we are solving and graphing inequalities, what we want to do first is combine like terms. And then we're going to move the variable to the left side. We're going to undo PEMDAS in order to solve. I think we did this. Undo addition and subtraction before you multiply and divide. And then you're going to flip the inequality symbol. We're multiplying or dividing by a negative. You guys remember that from Algebra 1? Then you're going to circle your solution. I'm going to abbreviate that. Circle solution on number line and shade appropriately. This is basically what we've been doing the whole entire time. Just some directions in case you forget. Okay, look at number 1. 2x minus 3 is greater than 5. We are going to treat this inequality sign like it's an equal sign, and we're going to solve as we normally do. If that's the case, how do I get rid of or what do I get rid of to get x by itself? We're going to get rid of this negative 3 by adding 3 to both sides. Good. Part of the trick of algebra is to line up everything. It just makes your life so much easier. So now I have 2x is greater than 5 plus 3 gives me 8. From here, what do I do? Divide by 2. Divide by 2. So x is greater than 4. That's my answer. We're not going to stop there. They want us to graph it. So I have 4. Will it be an open or closed circle?
Open.
Open, and we're going to shade to the right. You just follow the inequality symbol. All of those numbers will work in for x. If I wanted to put this in interval notation, from left to right, my graph starts where? What's my first number? 4, and I'm going towards what? Positive infinity. Does my 4 get a parenthesis or a bracket? Parentheses, same with my inequality. Sorry, my infinity. All right, number 2. 14x plus 7 is less than or equal to 7 times x minus 3. Before I move anything around, I want to get rid of this over here on the right side. I want to distribute. So 7 times x gives me 7x, and 7 times negative 3, negative 21. You can just rewrite everything else on the left side. We didn't even do anything yet. All we did was we just, on the right side, we undid the distributed part. Now, let's solve for x. What do you guys want to move first? Yeah, let's move the 7. I'm going to subtract 7x from each side. So that means I am left with 7x plus 7 is less than or equal to negative 21. and then we're going to subtract 7. And so I'm going to put my work over here. We have 7x less than or equal to negative 28. What do I do here? Divide by 7. This is always a big misconception here. We don't have to flip our sign here because of the negative 28. If my 7 was negative, then I would flip it. But since everything's good here, I'm going to keep my sign the same. And I'm left with negative 4. So when I graph this, I have negative 4, a closed circle, and I'm going towards negative infinity. Okay? So look at this. If I wanted to write this in interval notation, from left to right, I'm coming from where? Where's my arrow? What does that mean? I'm coming from negative or positive infinity? Good. Negative infinity. So that's going to be a parentheses. And my graph stops at what? Negative 4. And that's going to be a parentheses or a bracket? Bracket. Good. All right, number 3. We can do this 2 different ways, and I haven't decided which way I want to. Okay, for and graphs like this is definitely an and. We can split it up into 2, but sometimes it gets more confusing. So let's just work it out as it is. We always start in the middle. Okay, so focus your eyes here. My goal is to get that variable by itself, the variable which is t. So I first need to get rid of this positive 2. How do I do that? Subtract 2, but I'm not just subtracting 2 from the middle, I'm subtracting 2 from each side. Everyone is getting a 2 subtracted. So if I work left to right, what's negative 1 minus 2? Negative 3, I have my sign. I'm left with negative 2t because my 2's are gone, right? I'm left with negative 2t, and then I have my less than or equal sign, or less than or equal to sign. And then 4 minus 2 is positive 2. I'm still not done yet. I don't have that variable by itself. Now what do? I'll start in the middle again. How do I get t by itself? You're going to divide by negative 2, but you're going to divide everything by negative 2. So the middle gets divided by negative 2, the left gets divided by negative 2, and the right gets divided by negative 2. So on the left side, negative 3 divided by negative 2 just becomes 3 halves. You can leave it like that if you want. But because I'm dividing by a negative, what happens to my sign? It flips. So my sign here is going to flip from less than to greater than. I finally have t by itself. I flip my other sign. And 2 divided by negative 2 gives me negative 1. Good. I normally wouldn't have these like in order, but it's okay. I'm going to have negative 1 and then positive 3 over 2. Does negative 1 have an open or a closed circle? What about 3 over 2? Open. I know it's an and graph, so I'm going to make it a sandwich. I'm going to connect those two. All right, my interval notation would be negative 1 to positive 3 over 2 with the parentheses. All right, look at number 4. It's definitely going to be an OR graph. I have 2 different problems, okay? So we have to do these separately. I'm going to distribute this. 2 times x gives me 2x. 2 times 4 gives me positive 8, less than 6. Just go ahead and solve this one first. I'm going to subtract 8 from each side. So I'm left with 2x is less than negative 2. What do I do from here? Divide by 2. So I'm left with x is less than negative 1. Okay, that's one part of it. The other side. On the other side, I have negative x minus 3 is less than or equal to negative 7. Okay, how do I get x by itself? What needs to go first? The negative 3, right? Let's add 3 to both sides. And we're left with negative x less than or equal to negative 4. So negative 7 plus 3 gives me negative 4. So say, what do I do here? How do I get x to be positive? Divide both sides by negative 1. Negative 1, right? That's what's attached to my x. So I'm left with x. My sign is going to flip, so I divide by a negative, and I should get 4. So we have 2 answers here. Negative 1 and 4. It's an OR graph, so they're going to be going opposite ways. I need an open circle on the negative 1 and a closed circle on the positive 4. Go ahead on your paper, try to write the interval notation. Alright, so you should have parentheses, negative infinity to negative 1, or parentheses, union, which means my graph still keeps going, bracket 4 to positive infinity. That 4 is a closed dot, so it gets a bracket. Okay, we also have some special cases. The next 2, 5 and 6, you guys put down. This is all good? Okay. 5 and 6, special cases, which means that you do all your work, but something's not right. If I distribute my 3 to my x, I get 3x. 3 times 2, I get 6, is less than 3x plus 6. Well, this looks weird, right? Because they're both the same, right? So I can subtract 6, but we're basically going to get 0. It's less than or equal to 0, right? But 6 minus 6 gives us 0. If I do the same thing with 3x and subtract negative 3x, I still get 0. What that means is that, like last lesson when it was like 0 equals 0, that means all real numbers. Same thing here. You're just going to make, I think it's like a circle. Nope, nothing at all. You're going to put whatever number you have, which is 0, and you're just going to put a line with an arrow, meaning every number is included there. That means all real numbers. All real solutions. all real solutions. You ever have a number inequality and the same number is all real numbers? Let's look at this one. X plus 2 is less than or equal to x plus 4. Let's say I want to subtract 2. So I'm left with x less than or equal to x plus 2. And then I want to move my x to the other side. So minus x, I'm left with x is less than, I did something wrong. Oh, this is an x. What's x minus x? No? 0. I make that mistake all the time. It is just 0. That does not make any sense because we don't have a variable to compare anything. So your answer is just going to be no solution. You don't have to graph anything. You can abbreviate or you can write it out. Your answer is no solution. Make sense? All right, we are not doing the word problems today. We're going to do a day of word problems. Obviously, that won't be today. So that's why we're not doing them right now. So your notes are done. You survived. You can start on your homework if you